Hi, and welcome to the lesson about architectures. So different, I would say, solutions you can implement with streaming data. And believe me, when you learn a new concept, there is nothing better to understand it than having specific examples. And in this lesson, I will provide some of that kind of examples that will help you see different use cases for streaming pipelines. Of course, there are maybe others, but I think that with this covered in this lesson, you will have a quite good picture of streaming processing overall. And the lesson is divided into two parts. We will see the architectures from two different perspectives, the purpose and the consumer perspective. So let's start with the purpose and the continuous data generation. So here we simply take data, we write it to another place. And regarding this pipeline, it's a long-running application, so it's supposed to be running without interruption. Also, it's the application. Also, this pipeline transforms solid data. So for example, if we take the case of our data cleansing seen in the previous module, well, it takes some data, transform it, applies some data enrichment, and writes to a different place. And so the data, so the outcome is the new data generated. And finally, I called it utils in streaming processing because I think you are programming, and in programs there are a lot of places where people add classes like tools, helpers, utils, so that are very generic but could be divided into more specific domain related classes. And here the continuous data generation is that kind of thing, so it's kind of utils because it groups different specific use cases as data cleansing, as maybe stateful processing that we see in the second module, and so forth and so on. And one of these more specific examples is pattern detection. So here we have an example where we are receiving some numbers and we want to catch the sequence of these numbers. So the sequence is only previous number plus one, and here we can see that we detected only one sequence of four events. And here the application, the goal is to detect the patterns. The patterns are the outcome, and as a specific use case example, you can imagine this kind of job for any errors prediction. So for example, if your users always do a similar action that leads to the error, to the failure of your website, of your mobile app or anything, well, you can detect these patterns with this type of job and probably prevent the bad things happen, for example, by sending a notification to the user in the end. And by the way, the notification is another purpose of streaming jobs. So here we have again some dummy data in the input, and the goal is to detect whether the order number is greater than 2. And if it's the case, we will send an email to the user with that passed at least 3 orders, saying that hey, maybe you want this voucher or anything that you can do for marketing purposes. So here the outcome is notifications delivered either to an email or either to a mobile app and stuff like that. The next purpose of streaming pipelines is something that you already saw if you joined in the data ingestion module, the change data capture. So here we are reading the commit logs written by a database that are processed by the data capture job and written to a different streaming broker. So here the goal is to get the updates as soon as possible from the storage that is not natively kind of real time or notification oriented, because if you consume streaming data, you are doing it in a continuous way, whereas when you, for example, work with relational databases, you are doing it more in an ad hoc manner, so when you want. So even though if you have your consumer running in streaming way, without this commit log reading, you cannot necessarily see data changing in real time. And one of the end examples is to making this data address available for streaming processing. And there is also another the example or purpose that you maybe have seen in the previous modules, so data address generation. So remember, we will not always need streaming processing in many places, but pipelines will be enough. And for making them running, you will of course need data address storage. Well, you will need it's better to have them because for data address storage you can apply different storage optimizations like partitioning, maybe bucketing, and things that will make your processing much faster and easier. And it will also open other possibilities like ad hoc data querying or some data investigation. And here the outcome is the data from the streaming broker written to some data address storage. And here, as an example, as an application example, we can see that the goal is to make real data static for ad hoc querying. And now in the final part, we will see the consumer perspective. So there are two different architectures here. The first one is that we have a single consumer, meaning that only one application is allowed to read the streaming data. And very often once the event is read, it becomes unavailable for reprocessing and for reading it again. So the outcome is that we get anything we have seen so far. As an alternative, we can have multiple consumers with different specializations. So here we have the one consumer that is reading streaming data and writes it and is writing it to some data address storage, and another consumer that works on exactly the same data, but instead of writing data in the address storage, sends the notifications for the users. So the two examples we saw previously. And here it's very flexible. You can have a use case per application or even per business domain in your company because all the consumers have access to the same data. But of course, it may also bring some data security risk because maybe by distributing this access, you may be losing some of the control because there are maybe different companies, different business units accessing this data. And at some point you may not know what's happening with it. And as an outcome, you can globally implement any other patterns from the purpose perspective. And as a small drawback is that for some streaming brokers, there is some limited throughput in the output, especially for cloud-based solutions like, for example, Kinesis Data Stream, where there is I think 2 megabytes per second that can be read at most, and they can be read at most by all the consumers. So if you trigger, 2 consumers, each consumer will get 1 megabyte per second throughput. But it will probably enough for most of the use cases, but just be aware of that this flexibility doesn't come for free. And that's all for this lesson. Remember, if you're learning something new, it's always good to have the precise use cases in mind because I think they give even better picture of what we can do with the tool. And I hope that you experienced that in this lesson with streaming processing architectures. So thanks for watching and see you in the next lesson.